Okay, now the following section 6.6 talks about inverse trigonometric functions. I'm going to start with y equal the sine of x. This is a quick review of why we're doing this and why it's important for you to keep the answers matching. If I look at the graph of y equals sine of x, if I go up y equal 1 and come down to y equal negative 1, the graph of a sine consists of 4 main characteristics, 5 if you count the starting point. This is 2 pi, this is pi, this is pi over 2, and this is 3 pi over 2. Of course, the graph doesn't end there. The graph is infinite. But when we talk about an inverse, we discussed already what an inverse. We need it to be 1 to 1. We noticed that if I start at 0, I can't exceed pi over 2 to the right, and I can't exceed negative pi over 2 to the left. So, for me to have the sine y equal the sine of x, for this to be 1 to 1, I need to really restrict the domain between negative pi over 2 and pi over 2. Now, if I look at this graphically on the unit circle, or the quadrants I should say, that means for inverse sine, you could go as high as pi over 2 and as low as negative pi over 2, but that's in negative rotation, right? And this is for inverse sine of x. And if I look at y equal sine of x, to find the inverse, I would simply say x equal the inverse sine of y. And that's basically it, right? You could also say that is the arc sine of y, depending on which notation you follow. This is an angle. Alright? And if I look at y equal the tan of x, and if I look at the graph of y equal the tan of x, I'll notice the same problem arise. This graph is not 1 to 1. Between pi over 2 and negative pi over 2, a graph of a tangent looks like y equal x cubed, so to speak. Well, for me to talk about 1 to 1, it seems I need to restrict 1 to 1 if x is between, not included, between negative pi over 2 and pi over 2. So hey, I could add inverse tangent to the list. That is, if inverse tangent is between pi over 2 and negative pi over 2, then that will work as well, just like a sine. The only catch is you gotta be careful with tangent cannot equal pi over 2, well as inverse sine can. And if I do the same for y equal the cosine of x, well, if I look at the graph of cosine of x, y equal 1, y equal negative 1, except the graph of a cosine starts on the amplitude, runs down to the amplitude, back to the starting point. And if cosine was to match those two, then it wouldn't be as confusing, but it doesn't. This is 2 pi. This is pi. This is pi over 2, negative pi over 2, negative pi. I notice with a cosine, if I start from negative pi over 2 to pi over 2, we have a problem. Instead, I could start on a 0 and I could run all the way to as high as pi. So I can't really have one formula fits all. Instead, if I'm really dealing with a cosine, I should really consider 0 to pi over 2 all the way to pi. And that's where the inverse cosine of x exists, right? So here I'm going to say this would be 1 to 1 if I am running between 0 and pi. So this is 0, this is pi. You can be in this quadrant if you're dealing with an inverse cosine. Well, the good news, all the trig functions are positive in quadrant 1. If you're dealing with an inverse sine, inverse tangent, and it's negative, you must be in quadrant 4 in negative rotation. If you're dealing with an inverse cosine, you must be in quadrant 2 in positive rotation. And I'm sure you recall all of that. There is one graph you are responsible for. You're not responsible for the graph of inverse sine, inverse cosine. That doesn't come up. You are responsible for the graph of inverse tangent. And to graph this is how we do it. This is a graph you're responsible to know. So you can make sure if you don't know it, memorize it and learn it now. If I want to sketch the graph of the inverse tangent, well, remember the inverse, you switch x with y. Instead of x being between negative pi over 2 and positive pi over 2, it'll switch. Y would become between negative pi over 2 and positive pi over 2. And instead of y running between infinity and negative infinity, x would run between positive and negative infinity. And this is the graph of y equal the inverse tangent of x. As x approaches infinity, it will level off next to pi over 2, and as x approaches negative infinity, it levels off to negative pi over 2. And a quick small reminder, last time I taught the class, students seem to forget this part. Let me just remind you in case you've forgotten. Given a right triangle, depending on where you choose the angle to be, if you choose the angle theta to be right there, the side opposite of that is labeled opposite. The side opposite of 90 degrees is the hypotenuse, and the remaining side is the adjacent. If you take the sine of theta, you will get the opposite over the hypotenuse. The cosine of theta, you'll get the adjacent over the hypotenuse, and the tan of theta equal opposite over adjacent. And in any of those, you could say theta equal the inverse cosine of the adjacent over the hypotenuse. That's how you find this angle. You could say theta equal the inverse sine of the opposite over the hypotenuse. This is also the arc sine of the opposite over hypotenuse. You'll notice TI calculators use inverse sine, HPs use arc. And the same deal here, you could say theta equal the inverse tangent of the opposite over the adjacent. Now, we want to do some problems. This is a quick review. I'm going to alter some of these problems. So you notice I have 2a and a prime. I'm going to change the problem. This is asking the tangent of which angle gives me radical 3, and the answer is either you say 60 degrees or you say pi over 3, something you should memorize. If you need a calculator to do this, I suggest you start practicing without a calculator. And if I say where's this negative, you'll say, okay, well, the reference angle is pi over 3, but since it's an inverse tangent, and I know inverse tangent we said is negative in negative rotation, the answer will be negative pi over 3 or negative 60 degrees. If I say where does the secant inverse equal 2, remember that's an angle. This is saying where does 2 equal the secant of theta, or simply the reciprocal of this equals 1/2. And I know my 30, 60, 90 triangle. That means the angle must be, and the angle is the answer, that angle must be pi over 3 or 60 degrees. And if I am to put a minus in front of this, and you call this theta, and now you're saying negative 2 equal the secant of theta, or secant of theta equals negative 1/2, the reference angle is pi over 3. But since you're dealing with inverse sine, I wrote the same thing, didn't I? Since you're dealing with inverse cosine or secant, guess what? You are in quadrant 2, and pi over 3 in the second quadrant would be 2 pi over 3. And that would be my answer. If I look at number 4, I'm going to tackle that as well. If I look at number 4 and say, well, let's see how this works. Arc sine of 1, that's a special case. Where does the sine equal 1? Sine equal 1 right there. So it has to be pi over 2. Done. And if I make that 2 prime and make that a negative, then you're really looking at where does sine equal negative 1, and that turns out to be right there. The answer will be 3 pi over 2 is not allowed. If it's inverse sine, you must say negative pi over 2. And it's not the same thing, and that's not a simple mistake. If I'm looking at number 6, I need to figure out the angle. Now I know the inverse of the function undo each other, but this angle is not allowed. Why is that? Because 3 pi over 4 is in quadrant 2, and inverse tangent we agreed was allowed to be in quadrant 1 or 2. So this is negative, all students take cap, so it's negative 1. And if you say, where does the inverse tangent equal negative 1? The reference angle is pi over 4, but since that's negative, you are in quadrant 4, and you can only be there in negative rotation. My answer would be negative pi over 4. Do you need to do that? Yes. You need to know that and do that, because this keeps on coming back over and over. And what happens if I look at a problem and I notice that the angles don't match? Well, guess what? I call this theta, I call this beta. I'm looking for the cosine of theta plus beta, and I know that's cosine of the first, cosine of the second, minus sine of the first, sine of the second. So I need those 4 values, and I'm done. I go on the side and I say, let me take the first set. The first set, I'm letting theta equal the inverse tangent of 2. That means tan of theta equals 2 over 1. Well, if I draw my triangle, and I am in quadrant 1 because inverse tangent is positive in quadrant 1 only, opposite over hypotenuse, that makes this radical 5. Out of this, I need 2 values. I need this cosine. The cosine would be 1 over radical 5, and I need the sine. That would be opposite over hypotenuse. And if I take beta equal the inverse tangent of 3, which means tan of beta must be 3 over 1. If I draw my rectangle again, I am in quadrant 1. There's beta opposite over hypotenuse. This is radical 10. And out of beta, I need 2 values. I need the sine and the cosine. Well, the cosine would be the adjacent over the hypotenuse and opposite over hypotenuse. And there's the answer. Of course, you could simplify that. That would be 1 over radical 50 minus 6 over radical 50, right? And that would be negative 5 over radical 50. You could rationalize if you wish. And that would be negative 5 radical 50 over 50. That reduces to negative 1/10 radical 50. This is a fine answer, but if you want to match it with the back of the book, there it is. And it turns out we did this in trig, but we did that toward the very, very end. And this is crucial. That shouldn't be there. Alright, so those 2 problems are a must. That's really what calculus is based on. This was toward the end of the section 2.1, 2.2 in our trig class. If you've just taken trig, well, let's see how this works. If I'm looking at an angle, I don't know, and we really need to get this out of the way because this is coming up in 7.3 all over the place. This is an angle, which means I'm looking for tangent of that angle. I'm looking for the opposite over the adjacent. I go on the side and I say if theta is the inverse sine of x, the sine of theta will equal x over 1. My triangle looks like this. Opposite over hypotenuse. That makes this the square root of 1 minus x squared. And tangent is the opposite over the adjacent. And one more before I stop this video and start the next. If I look at this, if I call this angle right here theta, right? So actually, you know what? I do want to put that back in. But we are going to finish this section today. Normally I stop here, but depending on the class, in your case, I have 3 hours and 45 minutes, so I really need to go and finish those. So you're going to do 1 through 13 plus more because I'm going to finish this entire section today. If I call this theta, I'm looking for the sine of twice theta. So I'm looking at twice the sine of theta, cosine of theta. And again, you need that for the sections to come. On the side, I'll say if I let theta equal the arc cosine of x, then the cosine of theta equal x over 1. And if I draw my triangle again, I keep on saying, triangle, right? If I draw my triangle, I am in quadrant 1. Theta, adjacent over hypotenuse, that makes this the square root of 1 minus x squared. And I need the sine of theta, which is the opposite over the hypotenuse. And the cosine of theta, which is the adjacent over the hypotenuse. And that makes this 2x, the square root of 1 minus x squared. Now I'm going to stop here. I'm going to give you the whole video one shot and the whole PDF one shot.